Hello everybody, we are group 5 and our case deals with sample size calculations. Let's start the presentation with some humor. So what is sample size? Simply it is the number of units in a group under study. Sample size depends on number of things. For instance, are we dealing with observational study or interventional study? How much resources is available for this study? Ethics. Is it ethical to conduct an undersized study and expose the subject to potential harm when there is no gain in knowledge? And finally, does the study have adequate power? Now, some basic components of sample size calculations. A null hypothesis is the statement of no association between the exposure and the disease, and the alternate hypothesis is the hypothesis against which the null hypothesis is tested. Type 1 error occurs when the null hypothesis is falsely rejected and is commonly set at 5%. Type 2 error occurs when the null hypothesis is falsely accepted and is commonly set at either 10% or 20%. Power is the ability of correctly rejecting the null hypothesis when it is false. Conservatively, it should be at least 80%. Effect size is a generic term for the magnitude of the relationship between an exposure and an outcome. In epidemiology, effect size is usually the relative risk or odds ratio. Variation denotes the distribution of variable, and the critical value is the threshold value, which depends on the significance level and whether the test is one-sided or two-sided. Now let's move on to how sample size is calculated in different study designs and start with the case control study. Here our null hypothesis is that there is no difference in the leukemia risk for the people using smartphones such as iPhone and Blackberries and the people using regular cell phones. The people visiting MD Anderson Cancer Center in Houston between September 2011 and December 2011 will be our study population. The cases will be the people owning smartphones and diagnosed with leukemia at ages 18 to 59 at MD Anderson between the given date, and the controls will be the non-blood relatives of cases who own regular cell phones, never diagnosed with leukemia, and matched on age and gender. Now we use the formula given in this slide to estimate the sample size. Here P1 and P0 are the rate of exposure in cases and controls respectively. P0 is estimated on the basis of past literature. Here we wish to detect the effect size of 1.5 and M is the number of control subject per case subjects. After plugging in all the given values, we come up with the uncorrected sample size as 314 individuals in each group of cases and controls. We are estimating 20% of non-response rate, and when we account for this, we get 393 individuals. Which means we plan to enroll 393 cases and 393 controls in our case control study. Now let's look at cohort study design. The study question is: initiation of drinking at or before age 14 increases the likelihood of development of alcohol dependence in early adulthood, and our hypothesis is that there is no relationship between the two variables described here. Questionnaires will be administered to the students to ascertain the age at drinking initiation. The students answering yes to consuming alcohol will be our exposed cohort, and the students answering no to consuming alcohol will be our non-exposed cohort. Drinking onset will be determined from adolescent questionnaire responses. The sample size will be calculated by using the formula given in the slide. P0 and P1 is the probability of event in non-exposed and exposed group respectively. Here we wish to detect the effect size of 2 and the number of unexposed subject per exposed subject is 1. When we plug in the values as given here, we get the uncorrected N as 105. Based on past research, we estimate the non-response rate of 25%, and when we account for this, the corrected N will be 140. Which means we plan to enroll 140 students in exposed and 140 students in unexposed group to assess if there is any association between age at drinking initiation and the likelihood of alcohol dependence in early adulthood. Cross-sectional studies are one of the most commonly used study design. In the present study, we attempt to evaluate the correlation between the general health status and the socio-economic status in the US household population. We will limit our study to the city of Houston. The target population will be individuals between 18 and 65 years of age. Poverty will be the exposure variable, and the health status will be quantified based on the responses to the SF36 health survey. We use the given formula to calculate the sample size. R is the estimate of poverty and is 21% based on the US Census data 2010. The design effect is set at 2. We assume the non-response rate to be 30%. P is the number of individuals between 18 and 65 years of age and were estimated to be 65.1%. The average household size N was 3 based on the US Census data 2010. By plugging in the values, we obtain a sample size of 15,030 households for our study. We will now look at the sampling plan of our study. We intend to conduct a 3-stage cluster sampling. We will select census tract at the first stage. There are around 1,073 census tracts in Houston. The second stage will include selection of census tract segments within each selected tract. At the third stage, households will be selected within each selected segment or clusters. Now we have 15,030 households. Within each cluster, we will be selecting 20 households. So the total number of clusters in our study will be 752. Now every cluster will be selected from a specific census tract, and for each census tract, only one cluster will be selected. Thus, we will be conducting our survey in 752 census tracts with 20 households each in the city of Houston, Texas. Our next study design is an ecological study. Food deserts have become a common urban problem. They explain the relevance of our study question that neighborhood poverty level is associated with fast food outlet availability. We have chosen Galveston City as it presents unique opportunity for policy formulation and redevelopment after Hurricane Ike. Our target population will be adults from the 22 census tracts in the city. The exposure variable is the persons below poverty level, and we will follow a multi-stage cluster sampling similar to the cross-sectional study described previously. The density of fast food outlets in the census tract is our geographic outcome variable. This information will be obtained from InfoUSA listing. This is the formula we used, and we will need a total of 7,257 households. Thus, 330 households from each of the 22 census tracts will be chosen by the systematic random sampling. To conclude, in our study, the poverty level in 332 households from 22 census tracts in Galveston City will be compared and then correlated with the geographic density of fast food outlets.
Now we will look at the sample size in randomized controlled trials. Our hypothesis is that there is no difference between brief intervention by a trained professional and standard intervention consisting of informative pamphlets in reducing caloric intake in primary care populations. So our study population will be persons aged 18 to 65 years visiting the Family Medicine Clinic at Memorial Hermann Hospital, Houston, Texas between June 1, 2012 and May 31, 2013. They will be randomly assigned to Group 1 and Group 2. Group 1 will be an intervention group that uses informative pamphlets, and Group 2 will be an intervention group that uses intervention by a trained professional. Now the sample size will be estimated from the formula given in the slide. Here mu1 and mu2 are the population mean in groups 1 and 2 respectively, and we wish to detect a difference of 300 kilocalories between mu1 and mu2. After plugging in the values of population variance and critical values, we get an uncorrected sample size of 48. After accounting for an estimated non-response rate of 15%, we obtain the corrected sample size as 57 in each group. Thus, we will require 57 subjects each in Group 1 and Group 2 to show that brief intervention by a trained professional is more effective than standard intervention in reducing dietary caloric intake in primary care populations.
The next design is a quasi-experimental study. Our study question is whether alcohol education plus community control of alcohol sales to minors is more effective than alcohol education only in preventing teenage drinking. We will select high school students aged 12 to 20 years from Pennsylvania and South Carolina using a randomization table. The Group A children from Pennsylvania will have both alcohol education and community control of sales, since underage consumption of alcohol is prohibited with no exceptions in Pennsylvania. The Group B children from South Carolina will have alcohol education only, since the law has several exceptions to alcohol consumption by minors in South Carolina. These children will answer a survey on their drinking habits and then undergo alcohol education provided by trained professionals. They will re-answer this survey at the end of the study. This study design is relevant as we observe the participants in a natural environment but cannot control for extraneous variables. Plugging all the values in the formula and after correcting for non-response, we get the corrected sample size as 788. This means we will require 788 participants in each group to prove our study hypothesis. Thank you everyone for listening to our presentation.